Alright guys, let's go over the practice page for Wednesday, 8/25, variables on both sides of special solutions. You should have already watched Ms. Roundtree's notes, and I want to point out, I wrote some of these to help remind you. If you get that x equals a number, then that's one and only solution. If you get two numbers equal to each other that is not a true statement, then that means there's no solution. And if you get 5 equals 5 or 0 equals 0, basically a number equal to itself, then there are infinitely many solutions. Alright, so let's go through these. The first thing I'm going to do is I'm going to look to combine anything that is like terms on both on the same side. So these two are considered like terms. So I'm going to have 8n plus 1 equals negative 7. And then when I combine 5n minus 1n, that's going to be 4n. Now I'm going to look to get my n's on the same side. And when I do this, I try to keep my n's positive. Doesn't matter if I move left or right, I try to keep my n's or my variables with a positive coefficient. So if I look, I got a positive 8 here and a positive 4 here. So if I subtract 4n on both sides, that's going to make sure that when I work this out, I get a positive answer. So those cancel, and I am left with 8n minus 4n, which is 4n plus 1 equals negative 7. Then I need to start undoing terms or using inverse operations to get the n by itself. So I subtract 1. 1 minus 1 cancels out, and I'm left with 4n equals negative 7 minus 1 is negative 8. And the next step would be to get rid of that 4. It's connected by multiplication, so I need to divide. And I end up with n equals negative 2. Okay? Number 2. Again, look for any like terms. I don't have any on this side, so I know it's going to come down the same. And then on this side, the 8 and the 5 are like terms. So 8 plus 5 is 13 plus 7k. Alright, this time I want to get my k's on the same side, and I'm already looking, I notice I have the same thing. So what's going to happen, I'm going to subtract 7k from both sides. And something unique happens when you do this. 7k minus 7k, that's gone. 7k minus 7k, that's also gone. I'm now left with 13 equals 18. I have two numbers, all the variables canceled out, so I have just a number equal to another number, and that is a false statement, right? This is false. In other words, there is no solution. There is no number for k that you could plug in that would give you a true statement on this problem. Alright, number 3. Look for any like terms. b minus 7 is not going to have any, so it's going to come down. Here I've got 3 minus 3, which is 0. So I end up with b plus 0 or just b. Alright, the next step is to get my b's on the same side. So I'm going to subtract b and see what we're left with. So b minus b cancels out. On this side I am left with negative 7. b minus b, that cancels out. You may say, well, what's left? Well, nothing. So 0. So I have 0 equals negative 7. Again, that's a false statement. That's not true. The variables all canceled out, and I'm left with a number equals a number, and it's not a true statement. Therefore, this is no solution. Okay? Alright, let's continue on with number 4. I don't have any like terms. So all I have to do now is get my variables on the same side. Now, I could subtract 1n, but that's going to leave me with a negative on the right side. Or I could get rid of this minus 7n by adding 7n. Okay, what happens is negative 7 plus 7 cancels out. Now, don't forget, when you're adding over here, that's technically a 1n, right? So 1n plus 7n is going to be 8n plus 6 equals negative 10. Alright, Then the next step is going to be to remove the 6. We do that by subtracting, so minus 6. And we get 8n equals negative 16. And then the final step is to get rid of that 8. It's connected by multiplication, so we divide. And we get n equals negative 2. Okay, there's the first 4 done. So let's swap over now and take a look at the next 6. We're starting to get into some more complicated expressions. Again, look for anything you can simplify on either side first. I do have the distributive property here. So that's going to be negative 8x, multiplying that 4 through both parts, plus 4. That's going to equal 5 minus 8x. Now I need to get my x's on the same side. Okay, so I'm going to add 8x to both sides. And then negative 8x plus 8x cancels, negative 8x plus 8x cancels, leaving me with 4 equals 5. False statement, therefore no solution. Okay, moving on to number 6. Let's see what happens here. Again, I can't do anything with this on this side. Nothing to simplify. But over here, I again have the distributive property. Negative 5 times negative 1. That's going to be a positive 5x. Negative 5 times negative 6 is going to be a positive 30. You should notice something kind of special here. These two things are identical. I want you to watch what that means, watch what happens. But if I go ahead and work this out, I'm going to get my x's on the same side. Minus 5x, minus 5x. That cancels, also cancels, leaving me with 30 equals 30. This time, I end up with a true statement. That is a true statement. 30 does equal 30. And that means that the answer here is infinitely many solutions, or IMS, which you can abbreviate. It means any number you plug into this. You pick a value for x, plug it in, you'll get a true statement every time. Okay? Alright, moving on. Distributive property on this side. It's going to be negative 35x. And then negative 5 plus 2, or times positive 2 is going to be negative 10. And on this side, we have negative 10 minus 7x. Okay? So, first things first, let's get our x's on the same side. I have two options here. I can either add 7 to negative 35, or I can add 35 to negative 7. I'm going to do it in a way that makes my coefficient be positive. So I'm going to add 35x. That's the first time I've moved the x's to the right side, but I'm doing it specifically to keep my variable with a positive coefficient. So negative 35 plus 35x cancels out. I end up with negative 10. And then over here, negative 10. And then negative 7 plus 35. You can do that in your calculator. All right, you should get positive 28x. All right, so the next step would be to move this negative 10. So we're going to add it because we want to do the inverse of a negative 10 or a minus 10. So we're going to add 10 to both sides. And negative 10 plus 10 cancels. And over here, negative 10 plus 10 also cancels, leaving me with 0. So I get 0 equals 28x. Now, this one is different from this previous one up here. I still have an x. So I can't say that this is no solution. I have to solve for x. I divide by 28, which cancels that out. But it leaves me, because when I undo a division, the x does not go away. So I'm left with x. And what is 0 divided by any number? It's always 0. So my answer here is x equals 0 or 0 equals x. You can write it either way. That is a very different answer to no solution. 0 is a solution. It is a number, right? So when you get 0 equals 0, that's no solution. When you get x equals 0, that is one solution, because you do have a number that x equals. Okay? Be very careful with those types of problems. All right, moving on to 8. Not going to do anything on this left side, but on this right side I have distributive property and then this additional term. So we're going to have two steps here to simplify this right side. The first one is to distribute. So that's negative 12x, and then negative 2 times negative 8 is positive 16. and then plus 14x. Alright, so I'm going to come down and I'm going to continue simplifying. Do I have anything over here that I can continue to simplify? I do. Right? I have the negative 12x and the 14x. Those are like terms. So what is negative 12 plus 14? It's positive 2. So 2x plus 16. We're back in a similar scenario to this one up here, where when I subtract, let me swap pens so I do it in a different color. When I subtract 2x from both sides, I get left with a number 16 equals itself 16. Therefore, that is infinitely many solutions. Okay? Last two. Got to distribute on both sides. Got a lot of simplifying to do, so these are going to take the longest time. Be very careful with each step. Do one step at a time. So I'm going to distribute first on this side. It's going to be negative 9 minus 3x, because it's negative 3 times 1, and then minus 7. Bring that minus 7 down. Equals. Distribute here, negative 16 minus 2x minus x. Okay, I now have like terms. Negative 9 and negative 7 are like terms on that side. Negative 2x and negative x are like terms on this side. Okay, so I'm going to go ahead and combine the like terms on each individual side. So negative 9 minus 7 is negative 16 minus 3x. And then here I have negative 16, and then negative 2x minus 1, that's going to be negative 3x. And now we're starting to see a scenario that we should be kind of familiar with now. We add 3x to both sides. And what happens? The negative 3x is canceled, leaving me with negative 16 equals negative 16, which is IMS. If you make a very small careless mistake in any of this, forget a negative or something, you're not going to potentially get this IMS solution that you're supposed to get for this problem. So be careful. Alright, last one, number 10. I have distributive property, so bring down my equals, on both sides, so I'm going to do that first. Alright, so nothing to do with the negative 5n. I'm going to run out of space. Plus 3 plus 6n. Made it fit. And then on the other side, negative 56, because I'm multiplying through. Again, this is what I multiplied. And then plus 7n minus 7. Okay? Like terms, I do have like terms on both sides. I have negative 5n and 6n. And over here, I have negative 56 and negative 7. So we're going to combine the like terms that are on each side. Negative 5n plus 6n is a positive 1n plus 3. You don't have to put the 1. I just did so we would not forget, or so we would see that it's there. And then over here, negative 56 minus 7 is negative 63 plus 7n. Okay, again, now I'm going to have to do a little bit to get my n's on the same side. I want to keep my coefficient positive, so I'm either subtracting 1 or subtracting 7. And I know that if I subtract 1n on both sides, that I'm going to end up with a positive value for n. So I end up with 3 equals negative 63 plus 6n. And then from there we're going to add 63. And we get 66 equals 6n. Last step is to divide by 6. And we get n equals 11. So on that one, that is one solution. And I would like to point out, I don't know if you've noticed, you do not have to write n equals 11. One solution. Right? You don't have to write that. That's not necessary. This is enough for you to tell us that there's one solution. If you get this, IMS is necessary. This is the answer. Infinitely many solutions. This is negative 16 equals negative 16. That is not the answer. Okay? Infinitely many solutions is the answer. Here's the answer here. IMS is the answer here. No solution is your answer here. And IMS is your answer here. So make sure you understand what you need to put as the correct answer. It does not stop when you get to 16 equals 6. It stops when you get IMS, infinitely many solutions. Okay? Please remember to reach out to one of your teachers if you have questions or need extra help. Good luck. Thank you for watching.